Hello, welcome to Heat System Design. This is EST 204 and this is class 1, week 1, and I'll be giving you some introduction. If you haven't taken the time to look at the introduction video, how this course will be run through Blackboard, please do so. So this week we'll cover chapter 1, which is the concept of energy and why do we need to do uh, heat system designs for residentials. Okay, let me work this out. Okay, the goals of this lecture, we'll talk about energy. Explain what is energy consumption, and how do we put a dollar sign to that. Also be aware of where do we stand as a nation in terms of energy. Some of this information is from the textbook, and the textbook was published probably in 2010, so it's a little bit outdated. So if you want some updated information, it's kind of the same trend, but you can go to the Department of Energy and you'll see the new numbers. What are the possible ways to cut down energy consumption, and what does an individual can do? What can an individual do, and what can we do as HVAC technicians? Um, we'll list types of residential energy consumption and their relation to the seasons. And we'll start with the home energy. So, if we try to think about residential energy from the beginning, I mean, we wouldn't be here in New England if we didn't have the proper heating. Probably a lot of places in the south, like Texas or New Mexico, wouldn't be habitable without some kind of AC, air conditioning. However, Native Americans did manage to live in cold areas, and they did use some simple methodology to cool, heat, or ventilate their houses. So there are ways. If you go and look at primitive houses, whether in the Native Americans here, some houses in Africa or Asia, there are some ways to heat houses and cool them without the use of residential energy. Actually, as a matter of fact, if you look at passive heating and cooling, you can find some houses in New England that does not require any heating and cooling system, maybe a small stove fire, and that's all. So that's something to think about while we design heat systems for residential energy. So they used also white color houses. So there's also the orientation of the house makes a difference in how much energy does it absorb or reject. The color makes a difference. If you look at south of Spain, you will see a lot of houses that are painted white to reflect the sun rays and reduce the energy consumption for cooling. The chimney effect, if anybody ever had a tent or like went camping, probably they always use the chimney effect where you have a hole in the top of the tent, and that hole will draw air uh, using the air buoyancy. So it's good to use like nature and gravity to move things around, and the chimney effect is based on the air buoyancy and density difference. So we know that hot air rises and cold air sinks. So if we have a source of heat in a tent or in a chimney, it will naturally rise without any need for forcing it out. And as it rises, using the pressure difference, probably it will pull air in. And we'll talk about that elaborately later on. Building material has a big influence on heating and cooling. How is that? And we will see this when we do the little project where we do go and pick up material and see what is the insulation for that material and what is the heat transport through that material. So in the past, people used mud, hay, or stone for construction, and all these materials, they are natural, they are available, and they can help us kind of modulate the temperature inside the house. And yes, it's not very practical to mass produce mud, hay, or stones, even though it's still there, but the cost is very high. With the modern construction, we were able to find new, cheaper, and faster material to produce, but they came with some drawbacks. And recently, we became aware of our energy consumption. We're trying to kind of retrofit that and try to find material that has better resistance to heat loss and heat gain. So, as I mentioned, the Industrial Revolution and the boom of housing that happened between maybe the 50s and the 80s material was cheap, and they were trying to do a lot of mass production, and energy was relatively cheap, especially before the especially in the 70s. So there was not a big concern for house insulation, or there was not a lot of awareness about greenhouse gases and all these kind of issues with global with climate change and global warming. So we were able to pump as much heat as we want. It was very cheap. So we were able to save money by having cheaper or more economical building material. So now this story does not apply, and we have to be more conservative, since there's a lot of evidence that we have reached peak oil, and we cannot sustain having to produce this amount of carbon monoxide or dioxide. Electricity came in the 1880s. The light bulb was invented. More consumption for energy. The world's first power station came in the late 1800s. In 1908, 8% of Americans' home had electricity. That's really small. Compared to 1925, that's half the American homes had electricity. Probably now, I will say around like 98 or 99 American homes have electricity. So the consumption has been increasing, and the population has increased. Natural gas started in 1930. Now we have 50% of natural gas resources. The population, the human population in general, has increased. It doubled in the last century from 4 billions to almost 8 billion. So that's really a lot of consumption. So the need for us to be more conservative is there, and to find ways to have a sustainable way to heat and cool the houses. So today, and by today that means like 2010 probably, 80% of homes has ACs, air conditioners, and probably it's more than that. There are more needs for people to install air conditioners in New England now than before. As you have seen, this summer was 2020 was the record of heat, of hot days, and this will continue to have more temperature every summer. So there will be needs for installation. It's good for us as business, but it's not good for the environment. So hopefully we'll find ways to make things a little bit better. In the US alone, we represent the 5% of the world population, and yet we use 25% of the world energy supplies. I mean, that is kind of a very big percentage. And with globalization, a lot of countries are trying to follow the US model, and as you can see, that is not sustainable at all. So as the other countries getting more advanced and more industrial, they are trying to live in the same lifestyle that we live here. Meanwhile, we have to correct our lifestyle in here to make this power consumption more sustainable. Okay, these things can get political. I try to stay on the science and technical part. So the global warming is fact and fiction. There is what's called climate change, which means the cold climate is getting colder and the hot climate is getting hotter, more different droughts, different rain season. Everybody can see that. Whether we are the reason for that or the source of that, it's questionable to some people. But in the science field, 9 out of 10 scientists are sure that human consumption of energy is very responsible for climate change in general. So that's I think it's almost close to be a fact than just an idea. Greenhouse gases. So the use of increased gas production from by 16% in the 1990s to the 2000, and now we have more greenhouse gases. What are greenhouse gases? So we're not talking about freon or gases that are bad for the environment. These gases, kind of like carbon monoxide, carbon dioxide, they change the composition of our atmosphere, making the atmosphere more absorbent to heat, so it will store heat more, and by doing so the earth is not reflecting as much heat to space. So we're changing the atmosphere, which is the layer of air around earth, and this composition again has not a lot of interaction with the space, because again earth has gravity and keep that atmosphere around it. So we've been producing a lot of CO2, which is a greenhouse gas. CO2 is very useful for the plants. Plants use it to perform photosynthesis and has a lot of uses. However, the percentage of CO2 in the air does make a difference when it comes to greenhouse gases. Also, when you take the refrigeration course, you will learn about the EPA and the Freon and all the other gases that actually contributing to the atmosphere being more absorbent. And probably you noticed that some material can hold more heat than others. So is gases. So are gases. Some of them can hold more material, more heat than others. So that's what we mean by greenhouse gases. What about the import impact on the economics? So if we're talking about economics and importing energy and exporting energy, that's if we are not even thinking about the global the climate change, global warming, in terms of fossil fuel and burning all this kind of material, we're still importing a lot of oil, and the balance of sources of energy to the people who consume it is still in there. So there's also a big global economical impact for energy uses. Some countries have coal, some of them don't, and some countries that they don't have any coal resources, they have been pushed further to look at other resources like wind or solar. So our resources now are not sustainable. The way we are consuming energy, which is basically coal and fossil fuel, is not sustainable, and on a global level, a lot of countries are aware of that. There are some countries who are currently completely fossil fuel free, and by fossil fuel we mean coal and petroleum. So Finland is completely fossil fuel free, which is great. But again, Finland is a small country. Germany had put a very optimistic goal to be coal free by 2030. It's very, very aggressive, and the US also have some trains to kind of substitute using coal. So still in all these countries, I mean, even including Germany, coal is still the most dominant way to produce electricity. And again, coal has a lot of gases. I mean, has a lot of effect on the greenhouse gases, and also it's not sustainable. But we still have plenty of it, and we're trying to find ways to kind of wean from coal and use other resources. So the progress in renewable is slow, but it has been speeding up since the early 2000s, and people are finding more ways to kind of generate electricity without using fossil fuel. So there are a lot of promising changes and a lot of promising innovations, and if we can produce electricity without using fossil fuel, that will be a great step. And if you look at residential heating and cooling, it is very possible to heat and cool a house without using or burning any fossil fuel. You might ask me why. What are you going to do for heat? We can do a lot of heat pumps, and we can, at some point, we will have to subsidize for cold months like January and February with some kind of biofuel or something sustainable, which is very doable. If you think about it, the coldest months in New England is January and February, and these are the time when we need to maybe burn something, and there are sustainable ways to burn some kind of biofuel or biomass. So it's a work in progress, but there is some, and it's promising. So what is the difference between green energy and renewable energy? So green energy is the energy that does not produce gases that affect the greenhouse gases. So you might say that wind, solar are green energy, and they're also renewable because the source itself is continuous. We're not going to run out of it. Nuclear, on the other hand, is green energy because there is no emission, there's no carbon emission, so it's green source of energy. However, it's not renewable because there's a limited amount of plutonium or uranium in the earth. So that's the kind of difference. So it's good to have some kind of knowledge about these terminologies. And I encourage you to read chapter 1. It has a lot of good information about energy and sources and how to be used in residential. So gas, is it green or renewable? That's also debatable. There are some methane gas that is renewable. We can make that out of biomass. But is it green? No, because when you burn gas, it is producing CO2. So it's not really green. It's not really green, but it is renewable. What about wind? Wind is both green and renewable. We're not burning anything. We're not producing any gases, and the wind is always going to be there, and it's a continuous source. What about geothermal? What do you think of geothermal? Geothermal is both renewable and green, which is basically using the heat coming from Earth to heat, and we can use also that to cool. I will explain that later on more and how do we use geothermal. It's becoming a very popular field. There's I know a lot of people in New England that are installing geothermal systems. They are on the expensive side, but they are becoming more and more popular and more economical. Solar. Solar is two parts. We have solar photovoltaic. Those are the panels you see on roofs, and they produce DC voltage, which is good to be used after being converted to AC inside the house, and it can be stored as well. CSP is concentrated solar power, and it is renewable. It is effective, but it's not very useful in New England because we don't have a lot of sun heat here all months. But it still also can be used on seasonal basis. So this again from '97. This is very outdated. Just to tell you the difference and percentage between heating and cooling, and I don't think it changed that much. This is how much we use. I mean, I'm sure the dollar sign is completely different, but just give you an idea about the regions of the U.S. and how much they use for heating and cooling and water heating. I mean, if you notice, the Northwest we use Northeast we use most of our bills come from space heating. Cooling is not that much, and water heating still on the high side. There's way to help with that, and appliances. So that's for per household. You probably use around $2,000 a year for utility, which again it's a sliding scale, can change between town and how what kind of appliances you have, and that is a big area of improvement. If you let me use the pen. Like, I mean, if we look at this cost, this and this is a big area of improvement, and we can reduce that from 1,000 or 2,000 to at least to like up to like $500 a year. So that's really large. And also, if you notice that the Northeast has the most expensive power bills of all other regions, and probably because there is not a lot of cost when it comes to heating. So heating is a big part of the bill. So there are other ways there's many ways actually to mitigate that and make heating and cooling way much better. So market trends again, this is the projection. We are in 2020. This was made in the 90s, so I don't think the curve has changed. This is the current trend. We're still going really up, and this is what we want for conservation, and this is what the environment needs. So I think we're still in this little area here, but we're working on it, and you'll see a lot of houses now. They're doing a lot of retrofitting. And there's also a lot of initiative in Massachusetts, like the Mass Save initiative, where you can go and apply and get some tax write-off or rebates for new appliances. We'll talk a lot about insulation. How is that very important? It's something you do once, but it will save you a lot of money in the long term. So energy types in the U.S., we have coal. We said coal is still king. We're still burning a lot of coal. Gas is becoming more popular. Again, gas is way much better than coal or oil for heating because it burns better. What does that mean? Burns better. Well, it means that there is less harmful gases and less CO2. So, I mean, if we have to burn fuel, gas is one of the best sources. Renewable, we have solar, we have wind, we have geothermal. We also have a lot of biofuel. So biofuel could be considered as biomass. There is carbon, which is like kind of like man-made charcoal that you can use to fuel for heat, or you can use also biodiesel, which is basically frying oil that has been recycled and used to heat a house. This is a pie chart that's showing what is our power consumption in hot climate. So that's hot climate in the hot regions of the US. Let's look at cold climate here. So again, we said space heating is the biggest part. Appliance and lights are getting really better, especially with LEDs. We have a lot of LEDs now, and it's doing a lot of great work. Refrigerators, that's something that we cannot do without, and it's something we need to have. But there are, when we go over appliances, we can see there are ways to reduce the power consumption for fridges. And this is water heating, which also, again, there's a lot of nice leaps in heating water without a lot of footprints. So yeah, there's a lot we can do to conserve energy, and I would love to say that we would like to conserve energy and change our lifestyle without impacting it too much. I mean, if you tell somebody we need to save a lot of electricity, but you can't shower as much or you can't do this as much, probably you're not going to get a lot of response. It's better to keep people's lifestyle, do small alteration here and there that is not noticeable, than to just make a drastic change. There are small changes that we can do that will not impact our lifestyle, and especially if something that's been a habit or has been used for a long time, it's really difficult to change that. And the other point of view is, like, if you tell somebody, hey, this window is costing you a lot of money, but it will cost you $2,000 to change, he or she will be more reluctant to change it, you know. And that's why Mass Save will offer you a lot of rebates when you try to change a window or do some insulation. Energy shell in general, again, overall we're using a lot of energy for heating, refrigerators and lights. This is like if you have an inefficient system. This is what you do before updating your appliances and before doing installation. So if you look, again, this is also the Beeks, and if we notice, probably this is not the same in every state, but winter is very rough in New England, and that's when you need a lot of power consumption. The fall and the spring is when actually the power companies are doing a lot of renovation because they're not working as much. Summer probably have some peaks when it comes to power consumption because of the air conditioners. So probably this summer, the month of July and August, like 2 months, we had really a lot of power consumption, and probably the end of December, January, and February, we had a lot of consumption also for winter. So potential conservation means that things we can do. When, as technicians, there are options for us and things we can do. We can do thermal improvement. What does that mean? Better installations, better material for heat gain, and again, we'll talk about that in more details, and hopefully you will. I highly, again, I advise you to buy the book and use it as a reference. It has really good information that you can use later on after you graduate. We can replace all equipment. There's a lot of appliances that consume a lot of energy, and a lot of people don't feel the need to change them because they're running. But the running cost is really, really high, and it's very ineffective to keep that. I know people have attachment to all the appliances and they say, okay, I will just pay for the cost. But sometimes it's really better and more efficient to just change. And again, there are a lot of incentives to change all the appliances. All the heating systems, cooling systems. SEER, which is SEER, which is the seasonal effective efficiency ratio, has improved a lot. In the past, you get a SEER number of 12 for ACs. Now you can get up to 25. That's double the efficiency, which means half your energy bill. So that's something really, really effective. Lighting, you cannot imagine how much money you will save if you change your lights from incandescent to fluorescent, or from fluorescent to LEDs. And I will talk about that in a whole chapter. Electrical devices, what do we mean by that? Like all computers, all TVs, and I'm sure everybody now has an LED TV or LCD, which is way much better than the tube TV. All the appliances, all the ovens, washer and dryer, they always, it's better to upgrade those things if it's more than 10 years old. Running equipment, that's another thing. I don't know if you heard about smart grids or smart metering system. There are ways where you can control when the equipment is run. For example, washer and dryer, especially those equipment that consume a lot of power. So in some states like Maine and Texas, they have smart metering where you can actually see what is the power cost during an hour of the day, and you can program your washer or dryer or reschedule your washer and dryer to run during that time. So running equipment usually during the peak time is going to cost you more than the low time. If you look closely at your energy bill from Eversource or whatever you have, you'll see there are different pricing schemes, and there's a lot of information that can help you improve your efficiency. We can also inform and educate occupants about the cost of energy. The human factor is really, really huge. How do people react when it comes to energy? How do they behave? Do you leave things on that you don't need? Using sensors, using timers. These are all like ways to cut down energy consumption. And it does add up. Paying $300 a month for power is a lot. You can reduce $300 to $70. And it is possible. I know students who used to spend $700 on energy bills every month. After doing few adjustment, he was able to lower that to 150. That's huge, and I think it's a good saving for your money, and also it's good for the environment. So again, if you can deliver these messages to people you're trying to install equipment or educate some people, probably you'll get more response of getting more updating equipment and better installation. Reducing losses. So we are going to cool and heat, and if we can reduce the losses from the source, which is the air conditioner unit or the furnace, to the where you need it, that would be great. And again, we'll talk about the first and second law of thermodynamics, that you have to account for everything you produce in the system. And we'll discuss that a little bit further next week. But I just want you to think about that. Energy is money, and you're paying for every part of it, and you don't want to lose that between the cracks. So think about that. Something also we have to think about is air leakage, which is called infiltration. So there are two types of heat loss in a house. We have transmission, which is heat you lose through solids, through your walls, through your glass, through your floor, your roof. Air leakage is the holes inside your house and how much you have air exchange to the outside. Can we eliminate 100%? I mean, you can get close to 100%, but do you want that? No, the house should breathe and you should have the proper exchange. And so we'll talk about that again. There's a whole chapter about that. What is the minimum requirement for air exchange to the outside to maintain a healthy environment inside the house or inside the building. Also, we'll talk about hot water storage. Do we need to store water? We'll do some calculation. And when you store water, it's gonna lose heat over time. So you're basically losing energy as you go. So do we need to store water or just like heat it on demand? I will give you some options as well. Equipment maintenance. That's very important. An AC that's not been maintained every season probably is not going to perform as it should be. The SEER that we talked about, it keep getting lower if you don't do the maintenance and the proper tune-up. Same with the boiler. If you don't clean the boiler, you don't do the proper maintenance, it will lower its efficiency. It will run, but it's not going to be as efficient as possible. I'll give you an example, and probably you have experienced that. You buy a new car, the MPG is very high. After 20,000 miles, it still runs. The MPG will go lower from 30 to 27. Another year it will be 25, and so on, until 5 years later you might not do much maintenance on the car. The car might still run, but you probably have really bad gas mileage, and probably it will be you would have like affected the engine and the transmission. So following the maintenance, even though people don't do it, again there is an impact to that. And if you do the math and think about how much would it cost you if it broke completely versus if you do the proper maintenance, probably you're better off doing the proper maintenance all the time. Excessive heat gain in cooling system. That's something we also have to talk about. And probably you thought about that a lot this summer. Kuwait was really hot. How do we do simple tricks to eliminate heat gain? I bet you can design a house properly in New England that you will never need to have an AC, even with the hot days. And even if you do, there are ways to cool the house without even the need to have an AC. But again, we'll talk about the house structure and how can you use the weather and the ambient and also the surrounding to your advantage. LEDs and lighting. This is another area again we talked about it. How do you change equipment to produce less? To consume less energy and have higher efficiency. Our behavior again is the human factor. And is it realistic to have all these changes? Yes, we have to make it realistic. We have to make it realistic, and we have to make it small. And we don't want to do drastic things, just little things here and there. I mean, something consistent and continuous is better than something huge that is very that will be eventually discontinued. So I know not everybody wants to give up the truck and drive a Prius, but you can find something in the middle. And again, you can also have a truck and have a Prius and use the truck for some events, you know. So it's about like optimization. Let's call it this way. Let's optimize our behavior. Okay, so we talked about energy consumption. Why do industrial countries consume energy? We talked about that. We have different needs, and at some point we just didn't care about that, and we did not continue to go on a path where we care more about the long-term effects. What our current energy sources: coal, gas, and a little bit of renewable. We talk about renewable energy sources that are not going to run out. And what are the 4 types of renewable energy? Let's name 4 types. I can out of the back and say biofuel. You can say gas, solar, and wind. Those 4 renewable energies that we can think about. And there's a lot of other things like hydro. You can look it up also, and if you're interested in this kind of field. And again, if you find this subject very interesting, I think it will be worthwhile for you to work as an energy auditor, and we actually have really good job potential. So if you want, just we'll talk about that during the class time. I can tell you the possibilities of jobs when you do energy auditing and retrofitting installation. What are some of the energy wastes in residential heating or cooling? Some of the waste we have is like running the equipment where we don't need it, and a lot of leaks. We have leaks and we have energy losses where it's not supposed to be, and that could be easily fixed. Okay, so that's what I have for you for week 1. Welcome. Please read chapter 1 and let me know if you have any questions. Please post your questions in the discussion board. And there's a question in the discussion board that I hope that you answer. And I know it's a remote class, but I really hope that we can keep it as interactive as possible. Good to see you all, and we'll see you in the class time. Thank you.